Good day, students. Today we want to review the extraction of iron ore from the blast furnace. Last year in February, March, for the paper 0620, paper 42, question number 1 was asking students to explain the processes of the blast furnace, extraction of iron from the blast furnace. So question number 1 was actually saying, name the substance which provide for carbon, name the substance which provides the carbon for this reaction. Okay, so if you look at these three equations which were given in the paper, you have carbon plus oxygen. So question number 1, they wanted to know where does the carbon actually come from in the blast furnace. So if you check in the blast furnace, the substance which is the source of carbon is known as coke. So they put coke in the blast furnace in order to be acting as the pure source for carbon. But then question number 2 is also saying state the purpose of combustion of carbon in the blast furnace. Remember, we want to keep all the contents of the blast furnace in the molten state. So we need a lot of heat. One way of generating heat there is through the combustion of carbon. So combustion of carbon is very, very important because it's there to provide heat. Okay, so that's why we should actually have combustion of carbon in the blast furnace. Okay, and then question number 3 was a calculation there where you were supposed to actually calculate the percentage by mass of iron which is found in iron ore. Now, if you check, the formula for iron ore is Fe2O3. Okay, now we want to find the percentage of iron in Fe2O3. What we do is you go to your periodic table. There are 2 atoms of iron here. So what you do is you have to say 56 multiplied by 2 because there are 2 atoms of iron, and then over the total of this compound Fe2O3. If you check, the total will be 160, and 56 by 2 is 112. So I'm going to say 112 over 160 multiplied by 100, and if you do your calculations, you're going to get 70%. So your answer will be 70%. That was the answer for part B. Now, if you look at B part 2, okay, it says state the name of the ore which consists mainly of iron 3 oxide. Now, if you check the color of iron 3 oxide, this one, it's red in color, okay? And usually when things are red in science, we normally have the prefix Hem. Okay, so the name of this iron ore will be hematite, just like the color of our blood is red. So it contains a red pigment which is called hemoglobin. So the name of this iron ore is called hematite. The syllabus expects you to be in a position to name, to give the name or the common names for maybe zinc sulfide, copper sulfide, iron oxide, and so forth. But the answer which we expect here is hematite. Okay, and then it says describe how carbon monoxide is formed in the blast furnace. Okay, in the blast furnace you're going to form carbon monoxide, but then if you have carbon dioxide plus carbon, this reaction will give you carbon monoxide. Okay, and then if you actually look at what is happening here, this is reduction of carbon dioxide. So the answer which they required here is describe how carbon monoxide is formed in the blast furnace. Our answer will simply be reduction of carbon dioxide. Reduction of carbon dioxide. There is a reason as to why we are forming this compound, carbon monoxide. Carbon monoxide is very, very important, and there's a reason as to why we need it in the blast furnace. Okay, it says write the symbol equation to show the reaction that occurs when iron 3 oxide is converted to iron in the blast furnace. Okay, so we start off with our iron 3 oxide. It's going to react with carbon monoxide, and then when that happens, we form iron plus carbon dioxide. Okay, now if you check what is happening here, you're going to actually to find out that our carbon monoxide is actually going to gain an atom of oxygen, okay, from carbon, and then we'll end up with carbon dioxide. Okay, and now you need to remember to balance. You need to remember to balance your equation. Okay, this is actually a redox reaction. Okay, it's actually a redox reaction, and you need to be comfortable with redox reaction. Iron oxide, okay, is losing an oxygen to carbon monoxide, so it's oxidizing carbon monoxide. It's being oxidized, okay, so it's going to actually lose an oxygen atom. Carbon monoxide is gaining an oxygen atom from from iron oxide. So carbon monoxide is reducing iron oxide. So carbon monoxide is the reducing agent here. So it actually acts as a reductant in that equation. Okay, right. And then it says name the process by which iron is converted to from iron oxide to iron. Okay, so our process here, the answer will be reduction. Okay, this process is actually a redox reaction, but our answer to this question would be a reduction. Okay, right. So this is the these are the main equations which happen in the blast furnace. But also last year they went on to ask about these equations. So we want to answer question now which have to do with equation number 1, equation number 2, and equation number 3. That's what we want to do now. We have equation 1, equation 2, and equation number 3. Okay, right. So we want to look at the next question, which says, state the type of reaction shown by equation 2. State the type of reaction shown by equation number 2. So if you look at equation number 2, we're starting off with one compound, and then it's going to split up, and we have two compounds here. So this is some form of decomposition which is happening. But because of the presence of heat in the blast furnace, this decomposition caused by heat, we call it thermal decomposition. So we call it thermal decomposition because the decomposition is being brought about by the presence of heat. Okay, and then if you look at equation number 3, okay, metallic oxides, non-metallic oxide. Equation, the next question was saying, explain why equation 3 is actually an acid-base reaction. Your answer symbol here will be calcium oxide is a base, okay? But silicon dioxide is an acid, okay? Non-metallic oxide, acid. Metallic oxide, base. So in actual fact, we are having base plus acid. This is actually a neutralization reaction which is happening there because calcium oxide is a base and silicon dioxide is an acid. And calcium silicate in that aspect is going to be actually a salt, okay? And the common name for calcium silicate, is actually called slag, okay? Right. So if you look at this process now, which is happening here, it's a reduction process, and we are actually using carbon to extract iron from iron oxide. And the next question was asking us, why is it not possible for us to use aluminium? Okay, we can't use aluminium for this process. Why? Because in the reactivity series, aluminium is more reactive. Okay, so we cannot use aluminium for this process. Okay, aluminium is actually more reactive than carbon, so we can't use carbon to extract aluminium from aluminium oxide. And then we don't use a redox process for all those metals which are high up in the reactivity series. We actually don't use redox to extract the metals from their ores. We actually use a process which is called electrolysis. So when we are extracting aluminium from its ore, okay, we actually use what we call electrolysis. And the syllabus expects you to know the name of aluminium oxide. We said iron oxide is hematite, but the name of aluminium oxide is known as bauxite. Okay, so the syllabus expects you to be in a position to recall all that information. Okay, right. And then if we look at maybe the last two questions, which came under question 1 for last year in our paper 42. The last two questions, they were just asking, they wanted to know whether you remember your electronic configuration. Okay, right. Electronic configuration for aluminium ion, which has lost 3 electrons, is 2,8. Okay, if it's the aluminium atom, we are going to put 2,8,3 here from the periodic table. But you need to check. 3 positive means we have lost 3. So before it was 2,8,3, but now we have an aluminium ion, so we get rid of the 3. Okay, and then the last question was talking about the F. Okay, plus 3, like that. Okay, right. So if you look at F plus 3, okay, 3 plus rather, okay, its atomic number is 26. Okay, so it will have 26 protons. Remember, protons are found in the nucleus, they don't participate in chemical reactions. So proton number remains constant, irrespective of the fact that we are gaining electrons or we are losing electrons. Protons they participate if we are talking of nuclear physics, because they are found in the nucleus. But chemical reactions are governed by movement of electrons in most cases. Right, so they wanted to know number of protons. But now if you look at number of electrons, because we have lost 3 again, just like for the case of aluminium, we are going to have 3 electrons. Okay, right. So it makes sense, because 26 protons will give you 26 positive. If you say 26 minus 23, you get your 3 plus. So this was the question which came last year in February, March 2024. It was a straightforward question. In most cases for paper 4, where they say state, you just need to write a very short answer. Don't write long answers, because you'll be wasting time, and also you run out of space. Okay, where you're supposed to calculate, they will leave a bit of space. It means you're supposed to show your calculation, like the one where you're calculating the percentage by mass of iron present in iron oxide. They leave a bit of space because the examiner wants to know whether you're in a position to show you're working, or whether you're not just copying answers like 70% from nowhere. They want to see 112 over 160, and then the examiner is actually convinced that you know what you are doing. Okay, right. So this was question number 1, which came last year. I hope you have managed to understand, and hopefully if a question like that come in future, or if it's come in another version, you'll be in a position to make use of the answers which I've shared with you today. Thank you, and thank you for coming by. I will see you in the next session. Bye bye for now.